In this part, this is the second part of the video for design of flange. Here we'll be discussing about the design for flange. In this flange coupling, we'll discuss about the design of flange. So coming to the part where we ended in the previous video, design for flange. So firstly we have to find out the thickness of flange. As you can see in this procedure, we have designed till here, design for key. Now we'll design for the flange and for the bolts. So in this procedure, as you can see, we need to find the thickness first, then the shear stress we need to check, and then we need to find the outer diameter, that is this, we need to find the outer diameter, the whole outer diameter of the flange, and we need to find the thickness of this, we need to find this thickness, and then we need to check the shear, and finally the last part, thickness of protective circumferential flange, TP. This is this part you can see here, this is the thickness, and this is TP, and this is TF. This is the flange thickness, and this is the thickness of the protection. This part which you can see here, this is the thickness of the protection. So let us go with the design for flange. Thickness of the flange TF, that is given as 0.5D, 0.5 into 50, that will give you 25 mm. So this flange will be 25 mm thick. Next, check for induced shear stress in flange. The equation for that is T max or T is equal to pi by 2 capital D raised to 2 into sigma tau C into TF. This capital D raised to 2 is the diameter of the hub, as you have already seen here. Diameter of the hub, we need to use this diameter 100 here because the shearing action takes place at this junction. So this is basically the hub, this is basically the hub. So we need to find take the diameter there. See in the equation here, T max is 895,000 pi by 2, D is 100 into tau C into TF. TF is 25, which you just found out here. So finding that tau C, keep the tau C at the other side, transfer the things to the opposite side. 895,000 into 2 divided by pi into 100 raised to 2, 100 square into 25. That will give you 2.27 newtons per millimeter square, which is less than 14. So this indicates that the design is safe because 2.27 is very much less than 14. So next, now we have found out we have checked for shear stress. Now we'll find out the outer diameter and then the thickness of the outer protective flange. So coming to this part, outer diameter of flange, that is, you can see here, the notation used for that is D0 or D2. The value for that is 4D, 4 into 50. So that will give you 200 mm. That is the outer diameter of the flange, which is this part. The outer diameter of the flange is 200 mm. So next thing, thickness of protective circumferential flange, TP, is 0.25D. 0.25 into 50 will give you 12.5 mm. That is the thickness of the protective circumferential flange, which you can see here. TP is this, or it can be this also. Both are TP. That is 12.5 mm. So it is this thickness which we are referring here. It is this thickness which we are referring. So finally we'll come to the design of bolts. Here we have some parameters. D1 or DN, small d1 or DN is nominal diameter or major diameter of bolts. N is number of bolts. D1 or DP, capital D1 or DP is pitch circle diameter of bolts. Tau B is shear stress in bolts. So let us see what we need to find out. First one, what we need to find is, as you can see in the procedure, we need to find design number of bolts first, then the pitch circle diameter and the shear stress. So going with that, number of bolts for shaft diameter 50, in the table 13.2 of the textbook RS Kurmi, you can refer page 86. They have given that the N will be equal to 4. We need to use 4 number of bolts for shaft diameter 50. Next one is pitch circle diameter of bolts. It is The pitch circle diameter is this diameter of the bolts, the central line, imaginary line here, that is the pitch circle diameter of the bolts. So we need to find that pitch circle diameter of bolts D1 or DP is equal to 3D. 3 into 50. D is 50. So we get a value of 150 mm. Some handbooks, HG Patil handbook is using the equation like 2 into brackets D plus 25. You can use either of these. Find D1 or DN. So in this we need to find out the bolt diameters, that is the diameter of this bolt which we are using, the diameter of this bolt here we need to find out that. So the equation is T max is equal to pi by 4 D1 raised to 2 tau b into n into D1 by 2. So we'll just see what are the values here. T is, as you all know, 895000. Pi by 4 is constant. D1 square, that is the thing which we need to find out. The next one is 30. 30 is tau b, which is given in the question. The shear stress in the bolt should not exceed 30, so we'll keep it 30 there. And 4 is number, n number of bolts. And 150 by 2, 150 is this pitch circle diameter which we just found out. It is 150 by 2. Finally, we need to find D1. Put the other things to the other side. 895000 into 4 into 2, 4 and 2 go here. And the whole other things, all the things go at the bottom. Pi into 30 into 4 into 150. So square coming to the other side will become a square root. 895 into 4 into 2 divided by pi into 30 into 4 into 150, the whole under root. D1, solve this, you get 126.6 and root of that will be 11.25. So that is the diameter of the bolts which we will be using. So finally, if you see for assuming coarse threads, the nearest standard diameter of bolts is 12 mm. So you will be using M12 bolts. So finally, this is how we design. So if you see the procedure once more, procedure or method for solving the flange coupling protective type. First we need to design the shaft, find torque, then find maximum torque, then find the diameter of the shaft. After that you need to find design for hub, outer diameter is capital D, length you need to find out capital L, shear stress, then check for shear stress. After that go for design of key, for key. Width you need to find W, these are there in the table. Width is W, thickness is T, length of the key is small l, taken as small l. Then check for shearing and crushing of the key. Finally, design for flange. Thickness of the flange is TF. Thickness of the flange is this part. This is the thickness of the flange. So this part here is the thickness of the flange. This is the flange. So next part, the shearing stress, you need to check the shear stress. Find the outer diameter of the flange, then thickness of protective circumferential flange TP. Finally, the design for bolts, number of bolts, pitch circle diameter and shear stress, you need to check that. So finally, after that, this is the procedure which we will be following. Thank you everybody.